to week 10 of the 30-week countdown for Leaving Cert Ordinary Level Maths from TheMathsTutor.ie. As always, the full 30-week countdown is on the website, so on TheMathsTutor.ie for all the full members. There's lots of videos in there, and we make a couple of videos available each week in these lessons for everyone who's watching. So the first one that we're making available this week is Arithmetic Sequences. So this is a video where we look at the first type of sequence that we're going to be seeing, which are called arithmetic sequences. And the second video that we've got a link for there is one of the exam paper questions. So this is 2013 paper 1 question 7. So both of the links for those are going to go into the chat, so you can check those out after this class. So when we're dealing with sequences and series, this is sometimes also called patterns, and you'll see that I have page 22 of my tables open. And I have page 22 of my tables open because I can see here that we have arithmetic sequences or series on page 22 of the tables, and we're going to see what those are. So we're going to be having a look at what we mean by arithmetic sequences and series. So here I can see, on page 22, I can see that we have our formula for arithmetic sequences and series. We're going to have a formula for something called the Tn and the Sn, where it says A is the first term and D is the common difference. And that's the first thing that we're going to be looking for here, is we're going to be looking for what is this common difference, or what do we mean by a common difference. So we're going to look at a couple of these sequences, and we're going to determine what kind of a sequence they are. So the first sequence we have here says 5, 8, 11, 14, 17, 20. And when I have a sequence like this, these are terms in a sequence. So this is my first term T1. This is my second term T2, so that's the number 8. My third term T3 is the number 11. My fourth term T4 is the number 14, and so on. If it's going to be an arithmetic sequence, so that I can use those formulas from page 22, and this is also called a linear sequence because this would look like a line if it was a function and I was drawing it. What I'm going to be looking for is the first difference is going to be the same each time. Okay, so what do we mean by the first difference? So the first difference is going to be where we're going to subtract. So difference means subtract. So I'm going to take a term and I'm going to subtract the term that comes before it. So I'm going to say T2 take away T1. So 8 take away 5, and that gives me 3. T3 take away T2, so that's going to be 11 take away 8, and I get 3. T4 take away T3, so that's my fourth term 14, take away my third term 11, and I get 3. And that pattern repeats itself, so each time in this sequence I take a term and subtract the term that comes before it. That's going to give me a common difference of 3. And that's the first time I looked for taking a term and subtracting the term that came before it. And when I get the same answer each time, we describe this as a linear or arithmetic sequence. And as we saw there on page 22 of the tables, we call our first term, which we've said is T1. So the first thing that's in our pattern here, T1, we give that the letter A. So in this sequence here, I'm going to see that A is the number 5. And we call the common difference the letter D, and that's what answer we get each time we subtracted those terms. So our common difference there, D, is going to be 3. That's the first type of sequence we're going to see here. The second type we're going to see is something called a quadratic sequence. Now, we've seen quadratics in a few of these lessons, so we know that this is where we have a squared term. So we're going to see that we have a squared term if we write a general formula for these quadratics. So this, because we deal with the letter N an awful lot, so we say Tn when we're dealing with our sequences and series rather than the letter X, are going to be in the form of an squared plus bn plus c. So we have our squared term and our letter And our A and our B and our C would be numbers or constants. So to investigate if something is going to be a quadratic term, this time we look for the second difference being the same. So this time we're going to do the same thing that we did. So my first term T1 is 4, my second term T2 is 9, my third term T3 is 18, my fourth term T4 is 31, and so on. And we're going to subtract. So I'm going to say 9 take away 4, and that gives me 5. And then I'm going to say 18 take away 9, and that gives me 9. And I'm going to say 31 take away 18, and that gives me 13. And I'm going to say 48 take away 31, and that gives me 17. And 69 take away 48, and that gives me 21. Now I'm getting a different answer each time, so that tells me that it's definitely not linear or not arithmetic, because I'm not getting the first difference to be the same each time. So once I've established that it's not linear, the next thing I'm going to look for is it quadratic? So now we're going to do exactly the same thing, but this time we're going to use these answers that we just got from our subtraction, and we're going to do the same thing again and subtract. So I'm going to say 9 take away 5 is 4. 13 take away 9 is 4, 17 take away 13 is 4, and 21 take away 17 is 4. So this time our second difference is going to be the same each time. So that tells me that this is a quadratic sequence. So we've got the same second difference, not the first time we did the subtractions, the second time we did the subtractions. And we don't have formulas in our tables here on page 22 for our quadratic, but we will see that we can have a formula for working out our A's and B's and C's using what we have here. Our Tn is equal to an squared plus bn plus c. The third type of sequence that we need to know about is something called a geometric sequence. And this time it's not a common difference, we see that it's a common ratio. So we would start the same way. So I'm going to take each of my terms and subtract them. So I'm going to say 12 take away 4, and that gives me 8. I'll say 36 take away 12, and that gives me 24. 108 take away 36 gives me 72. 324 take away 108 gives me 216. So I've got a different number each time, and that tells me that this is definitely not linear or not arithmetic, because my first difference isn't the same each time. So when it's not linear, we say, well, okay, let's see if it's quadratic. So we're going to do our subtractions again. So I'm going to be saying 24 take away 8, and that gives me 16. I'm going to say 72 take away 24, and that gives me 48. I'm going to say 216 take away 72, and that gives me 144. So again, I get a different answer each time when I do my second set of subtractions. So that tells me that this is not quadratic. So if it's not quadratic, the last thing I'm going to look for is it a geometric sequence? And if it's a geometric sequence, it means that each of the terms turns into the next term by multiplying rather than by adding. So we're going to be multiplying. So what I'm going to do this time is I'm going to take a term and divide it by the term that came before it. So I'm going to say T2 divided by T1. So in this case, I'm going to say 12 divided by 4, and that gives me 3. I'm going to say T3 divided by T2, which is 36 divided by 12, and that gives me 3. 108 divided by 36 gives me 3, and 324 divided by 108 gives me 3. So because I get the same number when I divide the terms, that tells me that this is a geometric sequence. Okay, so now that we have an idea of what our sequences look like, we're going to go and have a look at a couple of questions from the papers. So the first question that we're going to look at today is 2021 Paper 1, Question 6. So this question says the first 3 terms of an arithmetic sequence. So I'm going to mark that this is an arithmetic or a linear sequence, are -5, k, and 1. So these are my terms T1, T2, and T3. It says find k, and hence or otherwise show that the common difference is 3. So I'm looking to find the letter k first, and then I want to find the common difference, which I know is the letter d. So we're looking for what is the letter d going to be. If it's an arithmetic sequence, I know that every term minus the term that comes before it is going to be exactly the same. So T2 take away T1 is exactly the same as T3 take away T2. So in this case, I'm going to say T2 is K. Take away the T1, the term that comes before it is minus 5, is the same as T3, which is 1, take away T2, which is K. So K minus minus 5 is K plus 5 is equal to 1 minus K. And I'm going to rearrange this to get K's on one side and numbers on the other. So I'm going to add K to both sides and I'm going to subtract 5 from both sides. And that gives me 2K is equal to minus 4. And I'll divide both sides by 2 and I get that K is equal to minus 2. So that's my first part of my answer done. So the first thing said, find the value of K, and then hence or otherwise. So I can do this using any formula I want or any method I want, but we're going to hence, so we're going to use that answer to work out the common difference. So the common difference is what we get when we take a term and subtract the term that comes before it. So this time now we know that K, our second term here, is going to be minus 2. So I'm going to say minus 2 minus minus 5, and when I put that into my calculator, I get that D is equal to 3. So my common difference is 3 and K is equal to minus 2. The next part of this sum asks me to find T10, the 10th term of the sequence. Now you could just write out your pattern, so it doesn't say you have to do it in any particular way, but I'm going to use my formula from page 22 of my tables. So just to remind you of this formula here, I'm looking for Tn. So Tn here is my general formula for any pattern. So Tn is A plus n minus 1 times D on page 22 of our tables. And we always start by writing out any formula that we're using from our tables. So I'm going to write out that formula. So we're going to say Tn is equal to A plus n minus 1 D. So A was our first term. So the first term in this pattern is minus 2. And D is going to be, the first term in this pattern is minus 5. My apologies. So the first term in this pattern is minus 5. And my common difference that we've shown was 3. So we're going to substitute these into this formula. So Tn is equal to A, so that's minus 5, plus n minus 1 times 3. So this D is touching the bracket. It's a bit unusual that we have a multiply at the end of a bracket rather than at the front, but we're just going to do the same thing. So it just means multiply everything in this bracket by what's touching it. So I'm going to say plus 3n minus 3. And then we tidy that up by putting like with like. So 3n minus 8. That's my general formula for any term that's in this pattern or in this sequence, but they've asked me to find T10, the 10th term, so that means I'm going to sub in 10 everywhere I have an n. So I'm going to say that's 3 times 10 minus 8, and when I put that into the calculator, I'm going to get 22. So T10, the 10th term in this pattern, is going to be 22. Part 3 then says, find which term of the sequence has a value of 247. So this time I'm looking for n. So which term of the sequence means I'm going to be finding n equals to what? So remember, that's where we're saying T1, T2, T3. So we have our formula for Tn. So Tn was 3n minus 8. We worked that out up here in the last part of our question. So we're going to take that formula for this sequence and we're going to put it equal to 247 because we're saying which one has this value. So I put it equal to 247 and now we have an equation that needs to be solved. So I'm going to add 8 to both sides of this equation and I get 3n is equal to 255 and we're going to divide both sides by 3 and I get n is equal to 85. So the 85th term is going to be 247. Now you'd be writing out that for a long time to get to the 85th term, so it's much easier to use your formula than to write it out for that case. That's part A of that question. Part B then says the first three terms of a different arithmetic sequence are 4, 9, and 14. Okay, so it's a different sequence, but it's still arithmetic. So we're going to start with working out our A and our D. So A is my first term, which is 4. And we're going to look at our differences. So 9 take away 4 is 5. 14 take away 9 is 5. So my common difference is 5. And this time it says find the sum of the first 50 terms, and it gives me this little clue here of S50. So again, I'm going to go back to my tables on page 22, and we're going to look for our second formula. So our second formula here has Sn, and it says Sn is equal to n over 2 bracket 2a plus bracket n minus 1 bracket d, close the big bracket. So we're going to start with writing out our formula. So anytime we take any formula from our tables, we write that down, and then we're going to substitute into that formula to find S50. So we start with writing Sn. So Sn, our formula from page 22, n over 2 times 2a plus n minus 1d. And we're going to substitute. So Sn is n over 2 times 2 times 4 plus n minus 1 times 5. And again, we have this number touching the bracket at the end, but it just means multiply. So we say that's n over 2 times 8 plus 5n minus 5. So I'll tidy up what's inside the bracket first by putting like with like. So the 8 and the minus 5 go together to give me 3 plus 5n. And now we'll multiply everything inside this bracket by the n over 2. So that's fractions being multiplied. So top line by top line and bottom line by bottom line. And it's like that 3 plus 5n is over the number 1. So I'm going to say n multiplied by 3 is 3n. N multiplied by 5n is 5n squared, all over 2 times 1 on the bottom, so that's going to be 2. So that's my formula to find the sum of any number of numbers, and they've asked me to find the first 50 terms. So we're going to sub in 50 everywhere we have an n, so 3 times 50 plus 5 times 50 squared, all over 2, and that's going to give me 150 plus 5 times 2,500, all over 2. And when we put that into the calculator, I'm going to get 12650 over 2, which gives me that S50, the sum of the first 50 terms, is 6,325. So there are first two formulas that we come across on our arithmetic sequences from page 22 of our tables. The second question that we're going to look at, this time they're going to give me a pattern. So it says the first three patterns in a sequence of patterns containing dots and crosses are shown below. Draw the fourth pattern in the sequence in the box below. So I look at the pattern and I can see that we have one dot to start with. Then we have 2 dots, then we have 3 dots, and then we need to draw the next term. So I have it drawn out here, but just to show you where it comes from, is I said we had 3 dots, now we're going to have 4 dots. So I looked at the dots first, and then I'm going to look at the crosses. So we had 1 cross underneath our dot, then we had 2 underneath each dot, then we had 3 underneath each dot. So now we're going to have 4 underneath each dot. So we'll have 4 crosses underneath each dot, and we have 4 dots going across. So this is what pattern number 4 is going to look like. Okay, so 4 dots and then 4 crosses under each of those dots. It asks me to find a formula in n for the number of dots in pattern n of the sequence Tn. Now that's a kind of complicated way of wording it. What we're going to look at is we're going to look at the pattern or the sequence that the number of dots forms. So we'll say the sequence for dots. So when we look at the pictures that they've given us, we had 1 dot, then 2 dots, then 3 dots. And in the one that we drew, we had 4 dots. So we're going to say our sequence is going to be 1, 2, 3, and 4, and it's going to keep going like that. So here my first term in this pattern is 1, and we're going to look at what kind of a sequence we have. So we say 2 take away 1 is 1, 3 take away 2 is 1, 4 take away 3 is 1. So this tells me it's a linear sequence or an arithmetic sequence. So now we're looking to find Tn. So it's asking us to find the formula. What is Tn? So again, from page 22 of our tables, Tn is a plus n minus 1 times d. So sorry, that's a minus 1 times d. So we can substitute in. So we're going to say 1 plus n minus 1 times 1, which gives me 1 plus 1n minus 1. And the 1 minus 1 leaves me with just 1n, which is n. So my formula here is going to be that Tn is equal to n. So that's the formula for the number of dots. Part 3 says find the total number of dots in the first 20 patterns of the sequence. So the total number of dots means S. All right, so we're looking for the first 20 here. So we're looking for S20. So again, we go to our tables and we look up our formula for Sn, which is n over 2 times 2a plus n minus 1 times d. And we're going to say our a was 1, so our first term was 1, and our common difference was 1 as well. So we'll substitute those in for a and for d. So 2 times 1 plus n minus 1 times 1 gives me n over 2 times 2 plus 1 times n is 1n, or just n, and 1 times minus 1 is minus 1. And when we put like with like inside that bracket, I say 2 minus 1 is 1 plus n. And when I multiply this, the top line by the top line gives me n plus n squared over the bottom line by the bottom line is 2 times. So remember, it's not written as a fraction, but we could write that as a fraction over 1, and 2 times 1 is 2. So my formula for the sum of the total number of dots is going to be n plus n squared over 2, and we're asked to find S20. So everywhere we have an n, we're going to put in 20. So 20 plus 20 squared all over 2. And that's going to give me 20 plus 400 over 2. And when we put that into our calculator, we're going to get the sum of the total number of dots in the first 20 patterns turns out to be 210. The table below shows the number of crosses for the first 2 patterns. Complete the table and hence find a formula for the number of crosses in pattern n of the sequence. So in the first pattern, there was 1 cross, then there was 4, then there was 9, and in the one that we drew, there was 16. So we need to look at, well, what's happening here with this pattern? We could do this out using our formula for our first difference, and then that won't be the same in our second difference, but they're not giving us a lot of space here because what they want us to spot is that this is 1 squared, this is 2 squared, this is 3 squared, and this is 4 squared. So to complete this table, I'd be saying 5 squared, which is 25, and then 6 squared, which is 36. And the number of crosses is going to be whatever the pattern number is, so that's n, squared. So the number of crosses in this pattern here is going to be n squared. So it's nice to spot that pattern 1, 4, 9, 16, 25, 36. So all of your square numbers. Find the number of crosses in pattern 12 of the sequence. So here that they're asking me to find is we're saying how many crosses are in pattern number 12. So this is going to be n squared, and n is equal to 12. So the number of crosses is going to be 12 squared, which is 144. Find the number of shapes in pattern 10 of the sequence. This time we want our dots and our crosses. So we had a formula for our dots that was n, and for our crosses that was n squared. So the total number of shapes is going to be add those together. So I'm going to say n plus n squared is my formula for the total number of shapes. And we're being asked how many are in pattern number 10. So we're going to sub in a 10 everywhere we have an n. So I'm going to say 10 plus 10 squared, and that gives me 110 shapes in total. Part B then of that question gives me a different pattern. So it says the first two patterns in a sequence of patterns of crosses are shown below. Pattern 1 has one cross in it. Pattern 2 has one cross and two crosses underneath it. And it says the number of crosses in pattern n is Tn, and the general form can be written as n squared over 2 plus bn plus c. So this time we're seeing this n squared, so we know that we have a quadratic formula. It's told me that we have n squared over 2. So we said at the start of this that Tn for a quadratic was an squared plus bn plus c. But we've been told here in this case that a is going to be 1 over 2 because our n squared term is n squared over 2. So all we're going to have to find is b and c. So remember, that formula isn't in our tables. We need to know what our general term of a quadratic pattern is going to look like. So it says use substitution for n to write T1 and T2 in terms of B, C, and a number. Okay, so T1 is our first pattern, which has one cross, and T2 is this pattern here, which has three crosses in it. But what we're looking at first is that we're looking at T1 and T2. So we're going to substitute those in for n. So we'll say sub in for n in Tn. So my formula, Tn is equal to n squared, so that's 1 squared over 2, plus b times 1 plus c. So 1 squared over 2 is 1 over 2, plus 1b is b, plus c. So that's my T1 in terms of b, c, and a number. And I'm going to do exactly the same for T2. So I'm going to say 2 squared over 2 plus b times 2 plus c. And we're going to get 4 over 2, which is 2, plus 2b plus c. And then it says, hence or otherwise find the value of b and the value of c. So when I have two unknowns, so in this case, two letters that I want to solve, b and c, I'm usually going to use linear simultaneous equations. So I'd have two equations, but we haven't put them equal to anything except for T1 and T2. So what we want to look at again is how many crosses were in each of these patterns. So in the first pattern, T1 was equal to 1, and the second pattern, T2, was equal to 3. So we're going to take these expressions that we've written for T1 and T2, and we're going to put them equal to the number of crosses. So for T1, I'm going to say a half plus b plus c was equal to 1. And for T2, so that's T1. For T2, I'm going to say 2 plus 2b plus c, and that was equal to 3 crosses. So these look a little bit strange now because we normally get the letters on one side and the numbers on the other when we're doing a simultaneous equation. So I'm going to subtract a half from both sides. So I get b plus c is equal to a half. And I'm going to subtract 2 from both sides to get 2b plus c is equal to 3 minus 2. So 2b plus c is equal to 1. So now I have two equations in b and c, and we're going to solve these using simultaneous equations to find the value of b and the value of c. So we'll write out one of our equations. And we have to make sure that we have the same letter, or a letter that has the same coefficient but different signs. So I'm going to take this one here and multiply by minus 1, and I'll get minus b minus c is equal to minus a half. and I'm going to leave my second one alone. So 2b plus c is equal to 1. So for simultaneous equations, we add together everything on the left-hand side and we add together everything on the right-hand side of the equals. So I say minus b plus 2b, which gives me b, minus c plus c, which cross out, and minus a half plus 1, which gives me a half. So we've solved for b and we got an answer of a half, and we substitute that back in, and when we substitute it back in, I'm going to say a half plus c is equal to a half. So I'm going to subtract a half from both sides, and that gives me that c is equal to 0. And that's all that it asked me to do in this case, find the value of b and the value of c, but sometimes it asks me to write my general formula. So we had Tn given to us as n squared over 2 plus bn plus c, and we would just sub in for b and c. So that's going to be a half n plus 0, and we could tidy that up a little bit more just to say that Tn is equal to n squared over 2 plus n over 2. So hopefully you found this video useful on sequences and series. Just to remind you that there's 2 videos there in the chat. So the first one on our arithmetic sequences, so just to see a little bit more about that, and the second one from the papers.